Hello Eng 1060. In this video, I will be covering relational operators. As humans, we are always making decisions in our lives. The same set of processes need to be considered when coding as well. However, computers are dumb by default. So we need to tell a computer what to do through the code and also when to do it. So far in this unit, we have been instructing MATLAB to sequentially run lines of code. That is, it has been running in a linear fashion such that we start from the top at line 1 and we work our way down to the final line of the code. Let's consider the interactive Pythagoras M file that we created in a previous video. We have two input commands, one for our adjacent length and one for our opposite length. From those variables, we can then calculate the hypotenuse length. But what happens if a user enters a negative number for the length? Well, the following code will still compute the length because we are considering the squares of the lengths. And so for this problem, it doesn't make much of a difference, but physically, it is impossible to have a negative length. So what we can do is make MATLAB exit the code if the input length is negative. Here is a flowchart showing the process. We have the input command, which prompts the user for an input length. It then checks whether the length is negative. If it is negative, it will exit the code. If not, it will then run the following command, which prompts the user for a second length. It then checks whether this length is negative. Again, if it is negative, it will error and exit. If not, it can then calculate the hypotenuse and print out the result. So how do we actually get MATLAB to check whether the length is negative? We use something called relational operators. In MATLAB, there are several relational operators. Most of these are your mathematical expressions. So we have less than or equal to, greater than or equal to. Then we have the equals to, which is the double equal sign, and not equal to, which is the tilde followed by the equal sign. So for us to check whether a number or length is negative, we can simply say a is less than 0. Using relational operators will produce values of the logical data type. Logical values can be either true, which is represented as a 1, or false, which is represented as a 0. So using our previous example, if we had a, or our length, as equal to 5, typing in a greater than 0 will return a 1. Likewise, if we were to put in a is less than 0, this will return 0, which is false, as 5 is not less than 0. We can also operate on matrices. So consider having A as a row vector containing the numbers 3, 5, 7, 9, and 11. If we were to type in A greater than 5, we'll get false, false, true, true, true. This means that 3 is not greater than 5 for the first element, 5 is not greater than 5 for the second element, 7, 9, and 11 are all greater than 5 for the last 3 elements. If we were to use the greater or equals to sign, you'll see that the second element, which is 5, now becomes true. And finally, using the a not equals to 5 will give us true, false, true, true, true. Relational operators also work between matrices, but you need to make sure that the matrices are of the same size. So as an example, we have A is equal to a 4-element row vector. B is also a 4-element row vector. When testing whether A is not equal to B, it will check the corresponding elements. So it will check whether 5 is not equal to 2. In this case, it is true. Then it will check whether 4 is not equal to 4, which is false, and so forth. When we're checking whether A is less than B, it will check the corresponding elements. So for the first one, 5 is not less than 2, so therefore you get false. 4 is not less than 4, false. 3 is less than 6, so true. And 2 is less than 8, true. These are two more examples that you should go through yourself, where we have A is less than or equal to B, and also A greater than B. Notice that for this example, we have assigned the relational statement to a particular variable called C. Remember, it is always good practice to assign statements to variables. So far in this unit, we have used the single equal sign operator, which is used to assign variables. So if we were to say A is equal to B, the values of B will be copied into A. When using the double equals operator, it will actually compare the values from A and B. Here we have two vectors, A which is a 1 by 3 and B which is a 1 by 3 as well. When calling A double equals B, it will check whether 4 is equal to 2, which is false, whether 2 is equal to 2, which is true, and 0 equals to 2, which is false. In contrast, using the 1 equals operator, it will copy the values of B into A. So A, which was originally 420, becomes B, which is 222. There is also a logical function in MATLAB which converts numerical values to logicals, so either true or false. Numerically, non-zero values are true, while zero values are false. Here I have a vector comprised of 5, 0, 2, 0, 1. Calling logical A on this vector will produce true, false, true, false, true. This is because 5, 2, and 1 are non-zero numbers, so they return true, whereas zeros return false. The second example, B, contains negative numbers. Using a logical on B, so logical of B returns true, false, true, true. So regardless of whether the number is positive or negative, non-zero values will return true. The reason why we create logicals is to use them as indices for matrix addressing. Consider this example where we have time as a vector. We have a corresponding speed vector. If we were only interested in positive speeds, then we can test the relationship of speed greater than 0, and we can store this logical into an index variable. This will return true, false, true, true, false, true. This is because -10, or the second element, and the fifth element, -20, are both less than 0. We can then address our original time vector and speed vector with the index variable. What this will do is it will return values that have a true index. So it will go through, the first element is true, so it gives you 10. The second element is false in index, so it will get rid of the second elements. Third and fourth are both true. The fifth is false, so it will get rid of the fifth elements. And therefore you're left with positive speed times equals 10, 40, 55, 85. And the corresponding positive speeds are 10, 30, 60, and 60. In summary, code doesn't always get processed linearly, especially in more complicated programs. Relational operators can be used to test statements and return either true or false values. Relational operators work on both scalars and matrices. As a final thought for this video, is it possible to check multiple conditions in a single line?